Hello everyone, welcome to AI Anytime channel. In this video, we are going to explore the potential of GPT-4 vision in the healthcare domain. We're going to build an application that will help you analyze or assess the medical images. Now, it's very important to find out the feasibility of these multimodal LLMs, mainly in the healthcare industry, to find out if they are okay to use, for few of the use cases, like if you want to analyze, some medical images like CT scans, MRIs, X-rays, or also, just as an end user, if you want to upload, the symptoms or the anything related with your skins, body, etc. If GPT-4V or other multimodal LLMs like Lava, for example, or IDFix, are they okay to, use as a secondary option? Okay, of course, not to make any decisions, but if these multimodal LLMs can help you to, become more productive at your workplace. Now, imagine if you build a product for a radiologist using this multimodal LLMs, and of course you combine different racks with this to build a system or a product that will help radiologists to uh, do their job faster, of course, or the medical practitioners or even doctors, just as a secondary validation layer to find out, or a secondary opinion to find out if generative AI can retrieve some information from your similar case studies or similar historical data of patients and whatnot, right? So that's the agenda of this video. We'll see what kind of use cases we can look at in this video for healthcare industry. So if you look at here on my screen, I have an app, a Streamlit application that says medical help using multimodal LLM. By the way, multimodal LLM is like a very famous word nowadays in the industry, where LLMs have multimodalities of capability in themselves, where you can use text, images, audio, different dimensions of data. By the way, okay, you have these all these data have different dimensions once you process them, and once you vectorize this, and that's what multimodal LLM means, by the way. LLM language models which has vision capabilities, you can also call them a large vision model, okay, LVM. Now here you can look at option to upload an image. Now here I want to upload an image, and let's upload an image here. So let me, for example, I upload this image. You can see I have uploaded this image. A person who there's eye, and there's something wrong on the skin, right, on the top of the eyes and also below the eye, right? Now let's click on analyze image. Now once you click on analyze image, what happens is that the image goes to GPT-4 vision model, of course, with a prompt where we have defined some instructions. We have set some instruction in the prompt, and then GPT-4 model looks at that image and gives you some findings. So there is a structure for that. I will show you once we build this application. Now, if we look at the findings, we have categorized this response in three different categories on very high level. One is the findings, the other one is the next steps, and the last one is recommendations. Okay, so findings means what all the findings that GPT-4 is able to inference it from the particular image. So you can see it says the image presented shows a closer view of a closed eye with surrounding skin. There are notable erythematous patches. By the way, I'm very bad at this medical pronunciation, so if you are a doctor or if you work in healthcare, you will understand this. That are indicative of inflammation or irritation. The pattern and distribution of the redness, so you can see there are a bit of redness in the image, and any visible papules or small pustules suggest a possible diagnosis of a skin condition. It may be consistent with dermatological conditions such as rosacea, contact dermatitis, or an allergic reaction. So it gives you some, you know, uh, answer from its knowledge that this might be the possible region for that particular disease or symptoms or whatever. Now, the eyelashes appear normal without obvious signs of eyelid inflammation. So there is nothing wrong in the eyelashes, by the way. That is fine. Eyelid inflammation such as blepharitis, and there are no visible lesions on the eyelid margin that would suggest hordeolium or chalazion. Okay. The skin texture appears slightly rough in places, which could be related to the inflammatory process or the presence of comorbid skin conditions like acne. So these are your findings. So it gives you some findings, and in the next steps, it also gives you the next steps. What are the next steps that you should do if you are like a patient, or if you are just trying to get an appointment or reach out to a doctor? This will help you as a secondary opinion. And there are a lot of very famous use case, by the way, in the industry. Now, if you look at it, it says a full clinical history would be required, of course, to better understand any associated symptoms. You can have something from your past as well, right? From your past health conditions, such as itching, burning, or dry eyes triggers or whatever. Further examination with a slit lamp by an ophthalmologist may be necessary. So an ophtho, okay, who looks at the eyes and all, okay, a doctor. There are concerns about ocular involvement. Dermatological consultation is recommended for proper assessment and to rule out differential diagnosis. Okay, so that's on the next steps. Then you have some recommendations. What would you do as an early recommendations, like avoid touching or scratching the affected area? As we always say that if we have some allergy, let's stop it there and don't, touch or scratch that further. Over-the-counter dermatologic creams or ointments may provide some symptomatic relief, but this should be used after consulting with a healthcare. So we have put the instruction that please put all of these disclaimers. You can see there's also a disclaimer over here. The interpretation of this image is preliminary and is not a substitute for a professional medical examination and diagnosis. This is important, as if you are using AI or nowadays generative AI, you have to start putting disclaimer. You have to keep an end user in the loop. Now that end user can be anyone. It can be a doctor if you have built a platform for a doctor. It can be uh, you know an auditor if auditors are your end users. It can be like the normal people, the end user, if you have built any product for consumers, like a B2C product, right? So you have to start explaining them and keep them in the loop. That's what we are doing here in the disclaimer. We also have an option called ELI5. Now, Perplexity has this option. A lot of other companies, products builder who build AI products, they are now keeping features like ELI5, which helps you explain like you are 5 years old, because these are machine generated output. These are a machine generated output. For example, a radiologist will understand that, but what if somebody else who is looking at this, if you build those kind of products where these terminologies are becoming really technical, how can you explain these in layman terms? And that's what we do here. So if you click on yes, it will hide that answer and it will explain you as like a 5 year old. Okay, and that's what it will do over here. It will take a bit of time to do that, but you can see it over here. This picture is of an eye. The skin around the eye is red, which means it's irritated or inflamed. The redness and whatever, right? So it explains like a child, okay, a kid. Now, this is what we're gonna build. I will explain once we are writing the code in detail that what are the different use cases we can look at. This is not the only use case where you can use a large vision model or a multimodal LLM. You can use it in a lot of other industries. You can use it in your pharmaceutical industry. You can use it in your insurance industry for claims and whatnot. You can use it in mainly for software engineering. Software engineering, everybody is using it. You can use it for creating test cases, for building screenshot to code. There's a project, I have a video on that. So there can be a number of use cases where you can combine vision with LLMs. Okay, and that's what it is. So let's now jump into the code now and to start building this application. All right, so to build this application, we need only one thing, which is an OpenAI API key. I already have got it and kept in my env file. I will show you the way I have written the API key. It's OpenAI underscore API underscore key, everything in caps. You can get an OpenAI API key from OpenAI dashboard. You have to go to your dashboard to get the API key. Okay, you have to you make sure that you have paid at least once, because GPT-4 is now free for all. So you get the API key which has compatibility with GPT-4 Vision. Okay, now these are the requirements, three requirements that you need. OpenAI Streamlit, because you're gonna build a Streamlit application. If you don't know what Streamlit is, it's a library that helps you build web apps in Python. Very simple. Okay. Python.env to help you with the env files where you can keep your secrets, the API keys, by the way. Uh, let's create an app.py here. So that's what I'm going to do. And here I'm going to write all of my code. We need Streamlit. So let's get Streamlit as st, and the next thing is base 64 because GPT-4 you can pass your input in two ways. Either you pass an image URL if you have your image already hosted on some server or wherever on internet, you can get that shareable and usable URL. Okay, you can pass that to GPT-4 directly, it will take it. Otherwise, you have to create a base 64 out of that image. Okay, if you want to do it locally, I'll show you that. So these are the only two options to do that. While I'm creating this video, I don't know if there's any changes today. Import base 64, then we're gonna need import OS, and then from .env import load.env because that's what we're gonna keep here, and then from OpenAI import OpenAI. And by the way, you can also do this with Gemini as well, but I'm not a big fan of Gemini model. They created a lot of noise, but it didn't work out good for me in a lot of use cases. Load.env, and then here you have to get your environment key that you have. So os.env, and here you have to just give the same name that you have kept in that env file. So this is how I have defined OpenAI API key, and then you just do get env. Get env, and then you just define your OpenAI API key here. Yeah, it was showing me something, but now it's not showing. It's fine. OpenAI API key. So our API key is set now. Now let's have a client, any variable you can name it, and here I'm going to initialize OpenAI here. Okay, so let's have our OpenAI here. Now you can use this client and this respective functions, which is in OpenAI to like chat completions, for example. We can use that. Now let me just make it a bit smaller. We don't need that. Okay. Okay, our client is done. Now once we have our client, we need a sample prompt. So I already have, so we don't have to write here because I have a gist. Otherwise it will take me a time to write it, but I will show you what is that, how I have written the prompt. This is not the only way to write prompts. You can write it as your knowledge or your use based on your use case requirement. You can say, let me do an Alt G here. So once I do an Alt G, let me just read it for you. What I'm saying is you are a medical practitioner. So I'm assigning a role here in my prompt to the LLM or LVM, large vision model. I'm saying that you are a medical practitioner and an expert in analyzing medical related images. So I'm assigning this job or whatever role and the expertise, okay, of that, and then I'm also giving now instructions. You need to generate the result in a detailed manner, write all the findings, next steps, recommendations, etc. Right? You only need to respond if the image is related to a human body and health issues. So if you upload a image of a basketball, right, it will not return anything because we are setting that in our prompt. You must have to answer but also write a disclaimer. So we need a disclaimer saying that consult with a doctor before making any decisions. Remember, if certain aspects are not clear, for example, if you upload an image of ultrasound of a gallbladder, for example, LVM will not understand if that's an ultrasound of a gallbladder, of an ultrasound of your any other parts of the body, right? If there is no much information available, right? So in those scenarios, you just say that okay, unable to determine based on the provided image. Right? A bit of like declining the answer. Now analyze the image and answer the above questions in the same structured manner defined above. Right, now let's come down a bit, and then here I'm gonna. So what happens, right, when you work with Streamlit, if you have multiple buttons, check boxes, and other things, you basically need to handle a session state. So let's do that. So what I'm gonna do here is if uploaded file, this is what I'm gonna keep as my variable name. If uploaded file is not none or not in session state. Okay, so we have Streamlit as st. So st.session state. So let's do st.session state, and here then is not in. It will not be is here. If uploaded file not in st.session state, and then here you're gonna write st.session state dot uploaded file equals none. So first you make a none. Here we are just initializing the session state variable. So this is okay now. let's have a result. So if result not in st.session, not in st.session state. Okay, if result not in st.session state, and then you just do for st.session state dot result equals none. Now this is for that. Now let's write a function that will help you get the base 64 of your local image, because we are not going to get it from an URL, right? So for that, what I'm going to do is write a function called encode image, and I'm going to pass the image file name here. So image path, the path of the image. So define encode image with image path, and I'm going to first open that. So with open image path, and then yes, this is, excuse me, okay, with rb as image, let's keep it as an image file, and then excuse me, image file, and then here let's return. So return base 64 dot b, mm, b64 encode, where it is, base 64 encode, and then I'm gonna read the image file. So image file dot read, and then just decode utf-8, decode, and then utf-8. Now this will give you the base 64 of your image, utf-8, correct? Now this function is done. The next function that we're going to keep is create is, which is for interacting with GPT-4. So let's call that, call GPT-4 model for analysis. Okay, this is what I'm going to call here for analysis, and here I'm going to keep my file name, and that is nothing but a string, and then sample prompt equals sample prompt. This is what my sample prompt is, and here I'm going to first uh, get the base 64, because we're going to work with that. So base 64 equals encode. Let's use the function that we have written above that will help us get the base 64 of the image. So base 64 equals encode image, and here you pass your file name. That's what you have created. Now the next thing is I will take it from here. So let me just get that and explain to you. Now you can see we have messages, because we have also used it earlier in the lot of previous videos. Now here the message, this is a structure, this is a schema of GPT-4 vision, okay, that how you pass your inputs. Now in this messages, you have your role, which has an user of role, and then you have content. In content, we are passing two inputs. One is your text, which is nothing but the sample prompt that we have defined. So if you look at over here, this is a sample prompt that we have defined that will depend on what use case that you are trying to solve. And then we have an image URL, which has an URL base 64 image and detail high, which says a detail is like high and low. There are resolutions for your input image that you are passing to GPT-4V, that what kind of resolution that your image will have. Now detail high. Now this is how you define a message. So messages, and now you have to feed that messages. So in, let's do that. Now for that, I'm going to have a response variable that will have my response. And remember, we have client here that we have initiated in line number 12. We are going to use that client now. So client dot, it has a chat dot completion. So I'm going to use the chat. So chat dot completions dot create. And here I'm going to pass inside this. You can see it's a function, create function. It's showing you the model name. You can just read here the function, which has been explained by some of the intelligent assistants like tab9, kite, copilot, etc. in VS Code. Now here in define create, it says a model. So let's first give a model. So our model is nothing but the GPT-4 vision preview. I have the access to this, my that's why I'm using it, GPT-4 vision preview. And after that, the next thing that I'm going to do is messages. So messages equals messages, and then I'm going to pass a max tokens. Okay, what should be the max tokens here? So I'll just keep it 1500 or something. No, not more, but you can pass even more than that as a max tokens. Now what I'm going to do next is print, and let's do print response dot choices. That's how we pass the output, by the way, response dot choices, and then message dot content. Otherwise you have to pass your output message dot content. Okay, this is now, and then just return that. So I'm printing it in terminal to see if there is any error. Now return response, I will just return the same thing on the UI as well. So return responses choices, first one, then the message and the content of that message. That's what going to be my, let's increase that a bit by 2000 or something. I don't want to uh, spend a lot on my token cost, right? 2000. This is the function. GPT-4 is, by the way, a bit costly if you compare with 3.5 turbo and something. Now, this is what is a function that helps you to get the response from your image. Now, we have to write one more function, and that is for chat ELI. So chat ELI 5, I'm going to call this function as like chat ELI 5, pass your query, and here that what I'm going to do is ELI 5 prompt, a very simple prompt here. You have to explain the below piece of information to a 5 years old kid, or 5 years old rather. I will not call it a kid. Okay, so 5 years old, and it's already a kid, right, when it's 5 years. So, and then here I'm going to add my query. So let's add the query. The query is nothing but the output of your previous function. Now that's why I'm going to use again a messages here. So let's use a messages, and messages equals, and here the very simple thing is then you define a role. So let me just do a role again, user, and then after that content. So let's do a content thingy. So content equals eli5 underscore prompt. That's what my messages is. Now after that I'm going to have a response. So response equals, and I'm going to pass client dot chat completions dot create, and inside this I'm going to pass my model equals GPT 3.5 turbo. Here I'm not going to use 4 because it doesn't make any sense, because you were just here trying to make it a summarize to a 5-year-old kid. So turbo, so let's do turbo here. This is my model, and I'm going to pass my messages equals messages, and then after that I'm going to pass max tokens equals 1500. Keep it a bit shorter. Response, and then just return the response. We are okay with this, guys. Response choices message content, fantastic. We have written all the functions that we need. You can also build a fast API app with this now, because we have a function. Just use asynchronous functions with fast API templates. That's it. Now the next thing that we're going to do is, of course, work with the Streamlit thingy. So ht.title quickly, and here let's write something like medical help or something like that. Okay, medical image analysis using GPT-4 V. Okay, now ht.title, and then I'm going to have an expander where you can explain the app with ht.expander. Here you're going to pass a where is that, about the app or something, and then you can write ht.write, ht.markdown, whatever you want to write here. Streamlit supports markdown. ht.write, I'm gonna write upload an image uh, to get upload an image to get an analysis from whew, analysis from GPT-4. Okay, GPT-4V or something like that. Okay, GPT-4V. Fine. Expander is done. Now once you do the expander, the next thing that we have to do is uploaded file. So let's get uploaded file. So uploaded file, because if you remember, this is what we also created above when we were writing the state thing. So uploaded file ht dot how do we do that, file uploader. Okay, so ht dot file uploader, and we're gonna say upload your image, blah blah blah, and then you can give type for extension. So type, I'm gonna have jpg, png, and JPEG. Okay, so this is what we're gonna keep here. Now a type thing is done. Uploaded file is done. Now let's write. We have to do a temporary file handling. I want to save the file every time it has been uploaded, and then delete it after the second file is uploaded in the runtime. So uploaded file is not none. Okay, you can also see the uploaded file length of that or something like that. That's a different way. Now with temp file, I hope we have imported temp file. Okay. With temp file dot named, it has a function named temporary file. I'm gonna call it delete equals false for the first time. Delete false suffix os dot what is the path, and then we can split that for the file name. So os dot path dot split text. Where is that function? Split text again, and then uploaded file dot name. Uploaded file dot name, correct, as temp file, as temp file. Fantastic. So with temp file, now this is how you create. Then let's just write that. So we have to write that in directory. So temp file dot write, and then I'm gonna write that and get the value of that. So uploaded file dot get value. Okay, and it's a function. So get value. We are okay with this. Now here st dot session state, and I'm gonna have my file name and then pass tmp file dot name. Okay, now st.image, let's show the image once we upload that. I'm gonna say uploaded file, and then you can give a caption of that image. So caption equals uploaded image or something like that. Okay, uploaded image. Now this is done. So we are handling the temporary file temporarily. Now let's have a button. Once we click the button, the analysis will come in. So if st.button, and here I'm going to write analyze image. So analyze image, and after that, once you do that, if file name in st dot session state and os dot path dot exists, okay, exist, and then use, where is the session again, st dot session state and the file name, whatever. Okay, now inside this, if this is your thing, then st dot excuse me, st.session state, then you have a result variable. If you remember, we had a result, and then result, and then you call your function that you have, call GPT-4 model for analysis, and here we're going to pass that image which is in that session, particularly st.session state, and then you just pass the file name here. Now that's you pass your image. Now this will give you a result. Now let's do st.markdown thingy. So st.markdown to show the result. This will print the result. st.session st.session state, and then I'm going to pass my result, and then here I'm going to pass unsafe allow HTML equals true. Fantastic. This is okay, and now let's delete the temporary file once it is processed. So once you have the result, let's delete it. Okay, so os.unlink, I'm going to use unlink. Okay, os.unlink from that session. So unlink from that session state and just pass your file name. Fine. Now this is done. We similarly need it for ELI5. So if result in st.session state and st.session state file name. So st.session state, it would not be file name, it would be result, correct? Result. Yeah. A result, and here we need the ELI5. So result, and then you pass your st.info. Let's keep in info first. And I'm gonna write below is your result for ELI5 to understand in simpler terms. Okay, now this is done. Now if st.radio, and here I'm gonna write eli5, okay, explain like I am 5, okay, explain like I am 5, that's it. And then you give two options. There should be two kind of a radio button. One is no, and the other one is of course yes, and then equals, and then you first keep yes, which is correct, very good. And then if st.no no equals yes, okay. hmm if then let's have a simplify. Once yes is clicked, once somebody check, not click, once somebody check the radio button on the yes, it will give you the simplified result. So let's keep simplified result equals chat ELI function we're gonna call, and we're gonna pass our result here. Whatever result we have in that particular session, we're gonna get that result. That is your query. Now that is simplified result, and after that I'm gonna use markdown to show the result. st.markdown, and let's show it simplified result. Okay, and then keep unsafe allow HTML equals true. We are done with our code, guys. Now this is what we have to code. Let me explain that once very quickly. We have our all the libraries imported. You have load.env, you have your API keys, and then you have your client initiating where you have OpenAI class over here, and then you have a sample prompt where you are defining. Prompt is very important. Better your prompt, you will get better output. There is no doubt about it. And prompt engineering is again an art, I will say. I'm not the best prompter, of course, because I don't spend a lot. We have different people who write prompts, but I understand, of course, different prompting techniques. But you should focus on prompt engineering. It's really intuitive, and trust me, it really helps. It really helps solve complex problems because prompt is important to interact with natural language systems. With the LLMs, you can jailbreak systems if you master prompt engineering. So that's very important. Now you have your uploaded file here, a few of the session initiations. Then you have couple of functions. One is for base 64, the other one is to interact with the GPT-4, where you're passing your two inputs, sample prompt and your base 64 image. It can be URL as well from internet. Now you get your result. Then you pass that result with a simple prompt in a chat ELI5 function, and then you have your Streamlit thingy. Very much self-explanatory. Title expander to explain the app. Then you have an uploaded file uploader. You keep that file temporarily in your disk, in your memory, and then you delete that once the result has been processed, and then you pass the result in ELI5. Now let's run the code and see if we are getting the output that we were receiving earlier. To run the app, let's open our, okay, it exit. Let me just close this again. Otherwise, I have to close it from task manager. I'm going to open this in terminal. Okay, and then go inside and then dot slash activate c dot clean this streamlit run app.py. Once I do that, it should open a new tab. You can see it over here. Let me close this. Now you get the same thingy over here, medical help using multimodal LLM, whatever, and then you browse the file. Now once you browse the file, uh, let me first show you, let's upload. Okay, let's upload this. Now I'm uploading this image. You can see, and then I click on analyze. Now once you click on analyze, we are expecting, you can see it says running here. They had made some changes a bit on the UX front. You can see there's some New Year celebration happening on Streamlit running. It will give you the result. You can see that we got our result over here that says, let me make it a bigger so you can read it because that is important. The image displays an area of skin with multiple erythematous plaques, with some plaques topped by yellowish crust, you can see, and scales, which suggest active erosion or crusting. There are also areas that appear to be healing with changes in pigmentation. The distribution and appearance of the lesions could suggest a pattern consistent with Stevens-Johnson syndrome. If you are a dermatologist, if you're a doctor, please let me know. I don't know you in the comment box, or if you can reach out to me to tell me if these are the right responses. Toxic epidermal narcolepsis, they call it TAEN. Autoimmune skin conditions, severe cutaneous adverse reaction to certain medications, among other possible differential diagnosis. Next step, history should be taken, of course, including recent drug use, symptoms onset, and progression of the lesions. Physical examination needs to be conducted by a healthcare professional. This is correct. So if you are a healthcare professional, you would know this better. Laboratory investigation needs to be done. Complete blood counts, liver and renal function test. Blah blah blah. Skin biopsy can be also performed through histopathological examinations. If SGS or TN are suspected, immediate hospitalization may be necessary as these conditions can be life-threatening. Oh wow, I just took this from internet. I don't know if there's such a big disease. Uh, the patient should seek emergency medical care, the recommendation. Avoid self-administration. This is correct. Sometimes what happens, if you see some symptoms, we start taking medications on our own. For fever and all, it's quite bit. But if you are getting regularly, you have to check with a medical practitioner or to get to get it sorted. Otherwise, there's some can be life-threatening disease, and you will not know that, right? If you are just ignoring it. So that's very important. Maintain hydration, drink more water, of course. Follow supportive care measures, manage pain, blah blah blah. We have a disclaimer, as I said. This analysis is not a substitute for professional medical advice, diagnosis, or treatment. Always seek the advice of your physician or other qualified health providers with any questions or something like that. Now, this is what we are getting here, guys. This is what I really like the answer. Then you have ELI 5. Once you clicked it, above answer will be gone, and you will have an answer for a 5-year-old kind of an explanation. Very simple explanation. Okay, to get it. Maybe this can help you to make the end user understand. So if there's a patient who is coming to you, maybe you can use this to explain them. That picture shows a part of the skin that has a red patches. Some of these patches have yellow crust and scales look like they're getting better and changing color. This can mean that skin is not healthy and might be caused by a sickness called SGS or toxic epidermal necrolysis. It can also be caused by bad reaction to certain medicines, which is like we understand. We people like layman terms, we understand that. But not only with one image, right? We have to look at different images. Now, I want to show you something because, excuse me, sorry, we are also looking at feasibility of these models. I'm going to upload an image of gallbladder here. You can see this is an image of because I have downloaded this from internet. I'm going to click on analyze image here. Let's click on analyze image. So what I want to show you is that you can see it says, I'm sorry, but I cannot provide medical diagnosis or by this image appears to be a medical ultrasound which is typically used by professionals to observe a structure within the body. However, interpreting medical images required specialized medical training and context about if you have. So what we are trying to show here is that if that is not clear to an LVM, you should decline the answer. You don't have to always respond, right? It doesn't make any sense to uh, respond a false narrative or you respond which answer is not correct. Right? You should not do that. There should be some way you instruct your prompt, right? Or instruct your model, excuse me. Instruct your model through prompts that if you have to decline answer if you are not sure about it. And that's what we are doing here. Now, let's have this image and see what we get for this. This is some scalp or something. Okay, let's see if it gets it for this. So it takes GPT-4 is bit slower than other GPT models, but you can see it says the image the back of a person's neck with visible well demarcated scaly plaques. These are indicative of a skin condition that appears to be a psoriasis or something, which is a chronic autoimmune disease characterized by the rapid buildup of skin cells leading to scaling on the skin surface. The plaques are thick and red. These are the findings, typical of psoriasis or something. The plaques localization around the neck behind the ears is not uncommon for this condition. Redness and scaling suggest active inflammation. So this is what it shows. It shows the next step. It shows the recommendation, you know, phototherapy or systemic medications and whatnot, right? Now let me upload something as well here to show you. I had an image of what is this image? I have to see that. Okay, let's try it out this image. So I'm analyzing this image now of a lady, okay, having something wrong on the nose, unfortunately, and let's try it out what we get here. Okay, you can see here now it says it gives you the finding, but of course with disclaimer. Okay, it says an artistic representation rather than a photograph, so it gets it. Now, what we're also saying, it seems like a photograph. Somebody is taking a photograph, but it gets it. It says the individual in the image displays erythema or something, erythema, which appears to be centralized on the cheeks and nose, which might suggest a skin condition that causes redness or inflammation. It gives you the next step, it gives you the recommendation. Now, what we also gonna do is very quickly to show you something. Ooh, if I can show this. Now here this we are uploading an image of course retina. We're trying to find out about diabetic retinopathy. Now, why I'm uploading this image is because this is a very classical deep learning use case or a problem where in earlier we used to use deep learning models to find out or classify whether there are diabetic retinopathy in that image or not. And also we used to segment it. So there used to be segmentation, image segmentation, image classification we used to do. Now, if you look at here, it says the image appears to be a fundoscopic photograph of a human retina. What I'm showing you is that vision model now have the capabilities to do what deep learning models earlier used to do, because of course neural networks and all, that's how they have been trained on. But it helps you, you know, with a lot of different use cases even in one industry. Now, for this particular example in ophthalmology area or something where you need a secondary opinion of different retinal scans or a few different eye scans, how can you use this LLMs or LVMs to build some kind of capability? That is very important. If you see, it says the image appears to be a fundoscopic photograph of a human retina. Notable findings in the image are there is a round dark area which could suggest a macular hole or a similar retinal condition. There is an absence of visible retinal detachments or tears. The optic disc looks to be in normal condition with clear margins. The blood vessels appear normal without signs of cotton wool spots or whatever. Okay, there is no overt signs of diabetic retinopathy such as microaneurysms or hemorrhage. Okay, next step, it tells you for an OCT, optical coherence tomography, to evaluate the layers of the retina and confirm the presence of any macular holes. Right? It's fantastic. I love the response. It has a disclaimer, of course, and the recommendations. Now let's have one more any image we can upload here. Uh, no, let's try it out this. Yeah, this is what I wanted to show you. Now, this is an image of, if I'm not wrong, this is a human knee. And let me analyze. This is we are trying to find out if there is an ACL tear, okay, a ligament tear in the knee area here, and that's what we're trying to figure out. Now, this is a difficult image to analyze, and I hope that it tells you that you take a you go and check with your orthopedician or doctor to find out more in detail. And if you look at the answer, it says the image appears to be an MRI scan of a human knee joint. So that is correct. It's an MRI scan that we all know. It's a human knee joint based on this single image. That's also a point. Now, what you can also do if you are building this kind of capabilities, you are building this kind of products for the healthcare industry, what you also have to do, you have to upload the images and videos as well. You can take videos and extract the frames out of it. You can have multiple images, and then you instruct the model through a prompt that look at all the images and then come up with a conclusion. Then the model will have more information to derive from, right? It will have more information there, and it can inference it and gives you the right response. Look at the data, all the data that you have. You can also combine RAG here. You can have the patient historical data or the clinical historical data or clinical data that you have, case studies. You can combine it together and build a system that will be doing the job where they will help, the system or product will help the doctors, right? That's what you should do. uh, it says the knee joint structures. It gives femur, tibia, patella. You can see a patella over here somewhere. If I'm not wrong, this is a patella. Correct me if I'm wrong. These are the area where you have an ACL tear, if I'm not wrong. And then ligaments can be observed. There are no obvious signs of acute trauma such as bone fractures or significant displacement. Blah blah blah. Uh, there are no obvious sign of a ligament rupture. I don't know if that's a thing. And the joint space appears to be preserved. However, one must be cautious as not all pathologies can be ruled out with a single MRI slice. That's what I'm trying to tell you here. That if you have an MRI, you have multiple slices of your MRI scans. That's what it's important. Full assessment requires viewing multiple sequences and slices, and that's you make your decisions. Correct? You can see it's including different sequences T1, T2, STIR to assess soft tissues, cartilage, and bone marrows and whatnot. Fantastic, right? All right. I think this is what it is, guys. I wanted to uh, check the feasibility because a lot of people want to build this kind of use cases. They want to implement this kind of use cases. Want to build products where they want to combine these models. Okay, this can be one of your project as well if you are working anywhere as an intern, or if you are in a college, you can try it out, these kind of projects. Of course, you can learn more once you do it. Yeah, the code will be available on my GitHub repository. Uh, you can let me know your thoughts and feedbacks. And if you are a doctor or a medical practitioner or in the healthcare industry, your feedbacks will be really helpful, because then we will able to find out if those models are generating better responses or not, if there's going to be any kind of help to you people, right? So please let me know in the comment box. You can also reach out to me through my social media channels. The contacts are on channel banner and the channel about us. If you like the content, please hit the like icon. There are more than 200 videos on generative AI on my channel. Please share the videos and channel with your friends and to peer. Thank you so much for watching. See you in the next one.